Oh, hi.
Hi.
Oh, so you're back for another wonderful session in algebra. Have a seat. Sit down, sit down. And you also brought your book this time. Okay. Let me see if your book is any better than the one I already have. That way we can decide which book to work from. Okay, so last time was our first session, and we worked on sort of the background, fundamental things regarding algebra. And this time, okay, it looks like your chapter 2 is the same as the chapter 2 of my book. It's about solving equations. And it goes pretty much in the same order, solving one-step equations, solving two-step equations, except by the time you get to 2.5, 2.6, there are a few differences. But we'll go ahead and use your book. I think we should work off your book today. Okay? So what we'll be basically doing is flipping through the book, seeing what's covered in your book, and just trying to explain it in a way that will be easy for you to understand. Okay? Let me get my paper out. Okay. So, the last time that we were together, we talked about what algebra is. And can you tell me, do you remember what I said algebra was about?
Turning things into math problems and solving them for the unknown.
That's right. That is a very good answer. You know, algebra is just taking some real-world problem, some real-life situation, and turning it into mathematical symbols, and then solving for some unknown. And I think I gave the example of going on a family vacation, and you're trying to figure out how long it's going to take for you to get to your destination, given that you left your house, I think I said 10 minutes ago, and you're driving at, I believe I said 60 miles an hour, and you're trying to figure out how long it would take for you to get to your destination if your destination is 400 miles away. So that's a typical algebra problem. You take all of that information, you turn it into some sort of a bunch of mathematical symbols. You move them around, you subtract things, you cross out things, and at the end, you end up with something that says time equals 6.5 hours or whatever it is. I can't do it in my head. So that's what algebra is about. So let me just recap that. Let me just write that down, okay? So it's basically taking real life situation and turning it into a bunch of mathematical symbols. So you can solve for an unknown. Okay? I hope you can read my writing. It's not always the best. Can you read my writing?
Yes.
Okay. So, in doing this, basically, you end up with an equation, okay? The mathematical symbols form what's called an equation. And an equation might be something like the distance that you travel equals the speed times the time. So that's an example of an equation for the example that we're just talking about. But equations can be really, really complex. There are different types of equations to talk about different things in life and in nature. You can have something like distance equals, a falling object. The distance that a falling object drops, over time is, if it's thrown down, its initial velocity, initial speed, times time plus 1/2 acceleration of gravity times time squared. This is a d. That's the distance that a falling object that goes with time under the influence of gravity. Okay. So there are all kinds of equations, and so what we're going to do today is look at how to solve equations. And I know that you did a little bit of this in pre-algebra, but I do think that it's worth going over it again, because what I've noticed is that a lot of students didn't actually learn how to go step by step in solving an equation. What they basically do is they guess a number, plug it in, and see if it works, and then until they get the right answer. And that's not really the right way to solve an equation. And even if you were able to do that and get through the course and barely pass that part of pre-algebra, it's going to be more difficult to do that, because in algebra you get harder problems. And if you manage to guess and check and work your way through algebra with a very low passing grade, believe me, when you get to geometry, it's not going to work anymore, because those problems are much harder. Okay, so I just advise that we take our time and really learn the basic steps of solving an equation, because that's what algebra is essentially about. Okay, so today's lesson is very important because it's the foundation of the essence of algebra. In fact, the essence of most maths, because a lot of math is about solving equations. Even geometry problems get translated into equations. Okay? All right. So I think it's probably best to follow what's in the book, and I'll skim the section. We'll go section by section. I'll skim the section and then discuss it in a way that hopefully makes sense to you and that's easy for you to digest. As always, I encourage you to look at your book yourself. Don't just count on what we're doing here. Don't rely on what we're doing here. Take what we're doing here and look at your book again. And then this time, your book should make more sense. That's the idea. And again, when you're reading your book, you don't have to read every single word. Concentrate on the text boxes, the colored text boxes, and also on the things that are highlighted or bold or emboldened. Okay, that's what you should focus on. All right? Okay, so let's look at section 1 of your book. Okay, section 1 of your book is about using variables. Okay? And we sort of talked about this before. And basically, the variable is the unknown in the equation. When I was talking about the vacation and the car example, the variable, there are a couple of different variables, to be honest, but the most important one was the main unknown of the problem, the time. Okay? The speed is also a variable until you pin it down. Okay? The speed is a variable. The distance is a variable. Okay? Anything that's an unknown. In fact, any quantity of interest that can change is a variable. That's what, the name variable comes from, varying, something that varies is something that can change. So in a problem, if you have something that can vary, then that's a variable. In the situation over here where I talked about the distance of a falling object under gravity, okay, distance is a variable because it can change depending on what we say. The initial velocity is also a variable. The time is a variable. Okay, the initial velocity is a variable until it's specified, then it becomes a constant in a problem. Gravity is a variable all the time. So the reason I'm interested in this example is because I want to show you the difference between something that looks like a variable but it's not a variable, because it's always the same number no matter what you say. Okay, and that's g, the acceleration of gravity. No matter what you say, what the situation is, the acceleration of gravity is a constant. That can never change. And so that's not a variable. Not everything in a problem is a variable. The things that can vary, the things that can change, are what we call a variable. Okay. So let me just put this up here, and then talk about writing an algebraic expression. We did a bit of this last time. It's very important to learn how to write an algebraic expression because the whole point of algebra is translating a real life problem into these symbols. So that's the point. You can't do algebra if you can't take words and turn them to symbols. So I'm going to do a few because we did some last time. This is more like review. Okay, so algebraic expressions. And okay, this is basically, we're talking about variables here. And we're talking about algebraic expressions. So here's an example. 7 more than n, okay? 7 more than n. 7 more than n. Okay, that would become what in terms of symbols?
N plus 7.
Correct. N plus 7. Okay, where n is your variable, the unknown. Okay. The difference between x and 5. How would we write that? The difference of x and 5.
X minus 5.
Correct. X minus 5. Okay. What about the product of 20 and u? Not and u, but and the letter u, where u is the variable.
20u.
Okay. So product of 20 and u, when you write it, it becomes 20u, 20 times u. Okay. What about the quotient of 9 and w?
9 over w.
Correct. That's the fraction 9 over w. So 9 over w means 9 divided by w. It's also a fraction. It's also a ratio. They're all equal to the same thing. Okay? Now, in each of these cases, we had some variable, w, u, x, n. So variables are usually represented as a letter, okay? It could be a normal English alphabet letter, and if you do physics and higher level stuff, they start using Greek letters for certain variables, okay? So let's move forward. Let's talk about something a bit more involved than the simple examples that we've done. So it's going to be more expressions, more algebraic expressions. I just realized I should have said something about variables. So variables are usually written as a letter, okay? And variables are the unknowns. Since this is getting a bit crowded, let me use a highlighter. Variables are usually written as a letter, and variables are the unknowns, in the problem, okay? So, there's some equations that, there's some simple equations and then there's some more difficult equations. The simple equations have one variable, and then just a bunch of ordinary numbers, and you can move things around and solve them more relatively easily. But then there are other equations that have more than one variable, and those are not soluble, okay? You need to have as many equations as you have variables. If you have one unknown, you need one variable, you need to have one equation. If you have two variables, you need to have two equations. Otherwise, you can't solve for your system, okay? So that's something to keep in mind. So what I'd like to do is actually do what we're just doing, but translate a sentence, an English sentence that's a little bit more complicated, and turn that into an equation, okay? My coffee shop sells cups of coffee at $1 a cup. No, let's make it something at 75 cents a cup. Write the cost to you based on the total number of costs. Write an equation that relates the total cost to you based on the number of cups of coffee that you order, assuming that you order coffee for a bunch of friends.
What was the total cost?
75 cents. That's the whole point. The cost of each is 75 cents a cup.
Okay.
So write an equation that represents the total cost, that relates the total cost. That's a better way of saying it. That relates the total cost to the number of cups.
0.75C.
Okay. So that's an equation?
No.
Okay, why isn't that an equation, 0.75C?
Because it doesn't have an equal sign.
Thank you. An equation must have an equal sign. Okay, hence name, equation. So try it again. So cost of total number of cups of coffee ordered if each cup is 75 cents. So what is it?
How many cups did I order?
No, I'm saying the cost of the total number of cups. Give me an equation.
I don't have an equation for that.
Okay. The equation is the cost, which we'll call C. Remember, last time I mentioned that you should name your variable to match the quantity that you're trying to symbolize. So the costs equals 75 cents, okay, which is $0.75 times the number of cups. I would have said C for cups, but we already used C, so I'm going to say N for the number of cups. Okay? So cost equals 75 times number of cups. Okay? That wasn't too hard, was it? Okay. All right. Okay. So that's the first section. Let me see. Okay, so let's go on to something else, and that's solving one-step equations. So we just basically reviewed, because we did this last time, we reviewed how to translate regular words to equations. And so now we should solve the equation. Once you have an equation, you have to solve it. So we're going to work on solving equations, okay? And we're going to start with one-step equations, which are fairly simple equations, okay? So solving one-step equations, okay? So I'm going to show you an easy example. Say you had something like this: x minus 3 equals 5. The way you approach this is, I don't want you to guess, oh, let me guess that x is equal to 6. 6 minus 3 equals 5. No, that's not it. Let me guess that x minus 3 equals 5 is solved by x equals 8. Okay, 8 minus 3 equals 5. Okay, yeah, that's right. That works. Okay, I don't want you to approach it that way. Okay, what I'd like you to do is to realize that when solving an equation, you're trying to get the variable, the unknown, on one side. Okay, so look at the paper. You're trying to get this x on the left-hand side, on one side by itself, and then you're trying to move the numbers, pure numbers, over to the other side, okay? And so in this case, what you do is, to get rid of the pure number that's over here with the x, you add a 3 to both sides of the equation, okay? You add a 3. And so the negative 3 plus 3 will be 0. So only the x remains. And then 5 plus 3 is 8. Okay, so that's how you get the answer. Okay, so that's one example. Another example is let's say somebody told you that A plus 6 equals 9. And they said solve for A. Again, you want, and A is a variable. So you want A, eventually you want A to be on the left side by itself. And so you need to get rid of this 6. Okay? And what you do is subtract 6, because this is a positive 6. You subtract 6 from here. And if you subtract, and there's the thing about equations, whatever you do to the left-hand side, you have to do to the right-hand side. You're subtracting 6, you need to, from the left, you need to subtract 6 from the right, so that the equality will still be preserved. Okay, so you take away 6 from this guy over, these guys over here, you have to take away 6 from these guys over on the right-hand side to be fair. Okay, so when you do that, the left-hand side becomes A, and the right-hand side becomes 9 minus 6. So A equals 3. And so you've solved the equation. Okay? So now, so that was addition and subtraction. What happens when you have like things that are divided or things that are multiplying the variables? You know, the process is the same, okay? It's not much different. And so I'll give you an example. Let's say you had the situation. You're trying to find the number of dozens of eggs that you have, okay, so that you can know how many, let's say you're a farmer or something, and you're taking all these eggs to the market, okay, so you need to know how many cartons, okay, dozen cartons you need, to get. And so the first thing you do, obviously, is you count up your eggs. And you count up your eggs, and you find out that you have 144 eggs. And you know that you can only put 12 eggs in each carton. Okay, so the number of cartons and the number of eggs are related, by that factor of 12. So what you do is you say that 12 times the number of cartons, which I'll call C, equals 144. Okay, so in each carton you can put 12 eggs. All right, and so those cartons must accommodate 144 eggs. So how do you solve for the number of cartons? It's just like the examples before. We want this variable to be all alone on the left-hand side, okay? And the way to do that is not by, a lot of people want to say, okay, let's subtract 12 from both sides. You can't do that, okay? You can't just subtract 12, because I didn't say that this was C plus 12. I said it's basically C times 12. C times 12 is different from C plus 12. So you don't subtract 12 because this isn't a plus sign. Okay, this is a multiplication issue right here. So what you do to get the C by itself, can you guess?
Divide it by 12.
Okay, so you divide both sides by 12, so you divide by 12 both sides of the equation, because if you divide the left side by 12, you have to divide the right side by 12. So you divide by 12, and so the 12 disappears. The 12 becomes a 1. So it's 1 times C. and you divide 144 by 12. What's 144 divided by 12?
12.
Okay. All right. So basically, C equals 12. And notice how I changed it from 1C to C. Even though 1 times C is correct, the point is, in standard algebra, you want to just write C. You don't write 1 times C or 1C. You write C. You write the variable by itself. So the answer in this case is C equals 12. So you would need 12 cartons to get your eggs to the farmer's market. Okay, so that's a case of multiplication. Okay, what if you were given another example? What if you were given an equation where on the left-hand side you had your variable W, and it was divided by 9, okay? And you said W divided by 9 equals 7, okay? This isn't a plus or a minus. It's not a multiplication either. This isn't 9W. This isn't W plus 9. This isn't W minus 9. It's W divided by 9 equals 7. So we have to think of a new way to get the W over to the right-hand side. Okay, we can't just use any of the 3 things we did before. So what do we need to do to get the 9 over to the right-hand side and leave the W on the left side by itself? What do we need to do?
Multiply by 9.
Okay, that's correct. So we multiply this side by 9, and of course, whatever you do to the left-hand side, you have to do to the right-hand side. So multiply by 9, and so it's not really clear this way, but W over 9 times 9 equals W. And then 7 times 9 equals, what?
63.
That's right. So W equals 63. And so those are very simple one-step equations. Okay? And so with that, we'll take a few-minute break and then come back and do more complicated equations. Okay?